Example 1. Okay, the question is, in how many ways can 5 boys be arranged in a line for a photo session? Okay, let's look at the solution. Okay, since we want to arrange 5 boys, all 5 boys are being arranged. Therefore, it is, okay, so for the first box, we can put in boy 1, boy 2, boy 3, boy 4 or boy 5. That means we have 5 options here. Okay, followed by the second box. Okay, let's say we have already put in one boy for the first place. So left another 4 boys. So the second box is filled with value 4. Okay, next 2 boys out. That means for the third box we have, or for the third sitting position, we have only 3 more left. Okay, and you continue until we finish all. Okay, arranging all the 5 boys. Therefore, the number of arrangement can be written or can be calculated by multiplying all these numbers. So 5 times 4 times 3 times 2 times 1 equals to 120. Okay, or another option, we can use this formula 5p5. Okay, 5 arrange all 5, so 5p5 equals to 120. Example 2. In how many ways can a 4-digit number be made by using digit 1, 3, 5, 7 and 9? Okay, so here we want only 4 digits, but we are given 5 digits. Okay, so in order to form 4-digit number, we prepare 4 boxes, empty boxes. Then here we don't have any condition, so for the first box we have 5 options. Okay, for the second box we have only 4 left. Okay, followed by 3 and 2. Okay, for the last box we have already used 3 digits, therefore left only 2. Okay, so number of arrangement can be obtained by multiplying all these numbers. So 5 times 4 times 3 times 2, so equals to 120. Okay, example 3. In how many ways can the letters from the word fill be arranged in, okay, if there is no restriction? Okay, so no restriction, no condition to satisfy. Okay, therefore you can straight away, we are given 5 letter and we arrange all 5, so it is 5p5. Okay, or you may also use 5 factorial to find the answer. So 5p5 equals to 120. Okay, next question 2. If the consonants are always together, okay, we want the consonants to be together. So the consonants for this word is F, L and D. Okay, let's see the arrangement. Okay, so it can be arranged as this. Okay, so we want to make sure that the consonants are together. Okay, so this is first way of arranging. The second one, the second arrangement and the third arrangement, so that the consonants are always together. So altogether we have 3 ways to arrange so that the consonants are always together. Okay, now let's find the arrangement, total arrangement. So now for the letter I and E, okay, if we put the consonant all together, left letter I and E, so the arrangement of letter I and E is 2 factorial. Okay, the number of ways to arrange letter E and I and E equals to 2 factorial. The arrangement for the letter F, L and D will be 3 factorial. Okay, so we just want to arrange all these 3 letters, 3 consonants. Okay, it will be 3 factorial. So remember, first we identify how many ways to arrange to fulfill the first condition, that is the consonant have to be together. So that is 3 ways. Then we arrange letter I and E alone. So that will be 2 factorial. And then the other 3 letters, consonant F, L and D, that arrangement of these 3 letters will be 3 factorial. Okay, so total arrangement will be 3 times 3 factorial times 2 factorial. Altogether we have 36 arrangement. Example 4. How many different 5-digit odd numbers can be formed using the digit 3, 4, 5, 6 and 7? Okay, that is the first question, and followed by how many of these are less than 50,000. Okay. Okay, now let's find the total arrangement for 5-digit odd numbers. Okay, so first you prepare the empty box. Since we want to form 5-digit odd numbers, so you prepare 5 spacing for the numbers or the digits. Okay, now since the number that we want to find is an odd number, so it depends on the last box or the last digit. So for the last box we can put in 3, 5 and 7. From the given digit we are given 3, 4, 5, 6 and 7. So in order to form odd number we can only use 3, 5 and 7. Therefore we have 3 options. Okay, so after that we don't have any more condition to fulfill, so we move on to the first box. Okay, so let's say I have already one digit is already being occupied at the last box, so cancel out one digit, so left another 4 digits, or we have 4 options. Okay, so for the second box now we have only 3, 2 and 1. Okay, so multiply all this, you will get equals to 72. Or another way of answering this question, you also can do as this, where just now in order to obtain odd number we have 3 digits times with 4 factorial. Okay, because we have 4 digits left and we want to arrange all 4, therefore it is 4 factorial equals to 72. Beside other than 4 factorial, you may also use 4p4. Okay, now numbers less than 50,000. Okay, so now we want to find numbers less than 50,000. So in order to see the arrangement or the numbers, okay, first prepare 5 boxes. Okay, so now in order to obtain a number less than 50,000, it depends on the first box. So here the first box, let's say that we have only 2 options here, 3 and 4, so that we get a number less than 50,000. Okay, so I can put in the digit 3. Now remember, for the second question, you are asked to find how many of these are less than 50,000. How many of these? That means we are referring to the odd numbers. From the odd numbers, total we have 72. Out of these 72 odd numbers, how many numbers are less than 50,000? Okay, so we have 2 conditions to fulfill here. One, the number have to be odd number, and another criteria to fulfill. That will be the number have to be less than 50,000. So we have two criteria to fulfill. When you come across a question as this where you have two conditions to fulfill, so you have to fix one of it. So here I'm going to fix the condition where the number is less than 50,000. So in order to get a number less than 50,000, the first digit can be number 3 or number 4. So for the first step here, I'm going to fix the first box as digit 3. Digit 3. Okay, next, the last box with 3, 5 or 7 in order to obtain odd number. Since the first box is already occupied with digit 3, so we don't have 3 left, only 5 and 7 to be fulfilled at the last box. Okay, I hope you are clear with this. Okay, so we have already fulfilled the two conditions. The first one, less than 50,000. The last box, to make sure that we have odd number. Okay, so left. Okay, so if the first box occupied with digit 3 and the last box maybe it can be digit 5. Okay, so now we have only 3 options for the second box. So it can be, for the second box, we can put in digit 4, digit 6 or digit 7. Okay, so we have only 3 options here. Next, reduce 1 because already occupied with the second box. So for the third box, we have only 2 more left. And for the fourth box, we have only 1. So total arrangement, okay, multiply all these numbers and you get 12. Remember, for this case, the first box is occupied by digit 3. So it is a fixed number there. Okay. Now, or see, first box here, I'm going to occupy the first box with digit 4 now. So I'm going to fix the first box with digit 4 so that I get a number starting with 4. Okay, which is less than 50,000. We'll get a number less than 50,000. So now I'm going to put digit 4 in the first box. Okay, then for the last box, now we have, okay, digit 3, 5 and 7 left. Therefore, we have 3 options. 3 options. Okay, remember the first box is being occupied with digit 4, a fixed number, a fixed digit. Okay, the last box is being occupied by 3 options. Okay, that will be 3, 5 and 7. Okay, the rest of the box got no condition to fulfill. So let's say we have already occupied the first box and last box. That means we have another 3 digits to fulfill at the second box. Next 2, then 1. So altogether we have multiply all these numbers, digits, numbers. So you have 18. So the total arrangement will be 12 plus 18 equals to 30. Now, whenever you have the word or, okay, now first outcome or the second outcome here, in order to obtain a number less than 50,000, okay, you may start the number with digit 3 or digit 4 or. So whenever you are using the word or, then you change it as plus. Okay, so 12 arrangement plus 18 arrangement. So total is 30 arrangement altogether. Okay, example 5. 7 students are lining up for a photo session. In how many ways can they be arranged if the tallest is at the middle? Okay, so for the first arrangement, so altogether we have 7 students. The tallest have to be in the middle, so I put T to represent the tallest student. Okay, so T have to be in the middle. Okay, since we have only one option here, therefore it is 1. Okay, next, the rest got no condition to fulfill, so I can just substitute. Left another 6 students. Okay, then 5, then 4, 3, 2 and 1. Okay, so multiply all these numbers, or another option you can use 6 factorial, because only 6, the rest 6 other than the tallest student is already been placed in at the middle. The rest left another 6 students to be arranged, so it is written as 6 factorial or 6p6. Okay, or you use the boxes to fill all the numbers and then multiply all. So answer is 720. Next question, the 2 shortest are at the end of the line. So we have the first student, we have 2 short students, so they'll be lining up at the end of the line. So here we have 2 students to arrange. Therefore, for the first box here, we have 2 options. For the last box, once the first box is already been filled, for the last box we have only 1 more left. Okay, so the rest, another 5, will be filled in between these 2 short students. Okay, so therefore we have 5, 4, 3, 2 and 1. So multiply all these numbers. Okay, you'll get 240. Or another way of answering, since we have 2 short students, the shortest, so it is 2 factorial to arrange these 2 shortest students, so it is 2 factorial. The rest, another 5 to arrange, therefore it is 5 factorial. So multiply all this, again you will get the same answer, that is 240. For example 6, 4-digit numbers are to be formed from the digit 5, 6, 7, 8 and 9. Find the number of ways to form these numbers if the digits can be repeated. Okay, so if the digits can be repeated, okay, let's see how to solve. Okay, first thing, you prepare the empty box. Since we want to form 4-digit numbers, so prepare 4 boxes. Okay, we don't have any other condition, just the digits can be repeated, that's all. Okay, so for the first box we have 5 options. Okay, now for the second box we still have 5 because the digits can be repeated, so it is all the same. So each time we can repeat the digit, so it is 5 times 5 times 5 times 5. So altogether we have 625 arrangement. Okay, next question B. Now the numbers formed are even and the digits cannot be repeated. Okay, so here we want to form 4-digit number, so prepare 4 boxes. In order to form even number, it depends on the last box. So the numbers that we can put in the last box, that will be 6 and 8. That means we have 2 options here. Okay, the rest of the box we don't have any condition to fulfill. So for the first box we have another 4 digits, then 3, then 2. So multiply all this, so total arrangement will be 48. Okay, find the number of ways of forming 3-digit number from the digit 1, 2, 3, 4, 5 and 6 if no digits can be repeated. Okay, so 3-digit, so prepare 3 box. So for the first box we have 6 options, then 5, then 4. So multiply all this, you'll get the answer 120. Okay, now for the second question, it must contain a digit 5. Okay, this 3-digit number must have the digit 5. So we can, these are the locations of the digit 5. So altogether we have 3 ways. Okay, next. Okay, so let's say I fix the first box with digit 5. That means here for the first box, I can put in the digit 1, 2, 3, 4 and 6 because here I already fixed the first box with digit 5. So I have 5 options for the second box and 4 options for the third box. Okay, since I have the arrangement altogether got 3 ways of arrangement. Okay, so 3 times 5 times 4 equals to 60. Okay, example 8. Find the number of ways to arrange 3 mathematics books and 4 history books on a shelf if the 4 history books are always separated. Okay, let's see the arrangement. So here you have only one way to arrange so that the history books are always separated. Okay, therefore now we just arrange the history book and mathematics books. Okay, so for the history book it will be 4 factorial or 4 times 3 times 2 times 1, and for the mathematics book it is 3 times 2 times 1 or 3 factorial. So total arrangement will be 4 factorial times 3 factorial equals to 144. Next question. The mathematics books are always together. So let's see the number of ways to arrange the mathematics books so that they are always together. So these are the arrangements. So altogether we have 5 arrangements. Okay, 5 ways to arrange so that the mathematics books are always together. Okay, so the answer, so 5, the value 5 for the arrangement. Okay, next 4 factorial is the arrangement of the history books. 3 factorial for the arrangement of mathematics books. So multiply all this. So total arrangement will be 720. Now example 9. A 3-digit number is to be formed from 0, 2, 4, 5, 6, 7 and 9. Find the number of different 3-digit numbers, 3-digit numbers that can be formed, and no repetition of any digit allowed if the number formed with value less than 500. Okay, so let's see. We want to find a number, 3-digit number. So you prepare 3 empty boxes. Okay, now we want a number less than 500. Okay, therefore it depends on the first box. So the options for the first box will be digit 2 and 4. Okay, so we have 2 options here. Next boxes don't have any condition, therefore left another 6 digits. Okay, and followed by 5. So multiply all this. So your answer is 60. Or you can use 2 y2 because of the digit 2 and 4 in order to get a number less than 500 times, okay, left another 6 digit where we want to permutate 2 values, so 6b2. Okay, So equals to 60. Yeah? Okay, example 10. A code made up of 4 digits is to be formed from the digit 0, 1, 2, 3, 4, and 5. Find the total number of different codes that can be formed if digit 1 and 5 are to be side by side. Okay, so we want to form a code made up of 4 digits. Okay, so let's prepare the 4 boxes and let's see how many ways to arrange so that the digit 1 and 5 are side by side. Okay, so that is the first arrangement, second arrangement, and third arrangement. So altogether we have 3 ways. Okay, that is the arrangement alone. Now we need to arrange digit 1 and 5. So that will be 2 factorial. Next, okay, so in order to fill the digit in the third box now, we have already used digit 1 and 5, therefore left another 4 digits. Next we have 3. So total arrangement will be 3 times 2 factorial. 2 factorial in order to arrange the digit 1 and 5, and then 4p2 or 3 times 4 times 3. 4p2, why? Because we have 4 digits left, we want to arrange only 2. Okay, so multiply all this, you'll get 72. Okay, now for this case you have to be careful because we cannot put 0 at the first box, otherwise we won't be able to get a number made of 4 digits. We won't get a 4-digit number. Okay, so we are not supposed to insert the value 0 at the first box. So out of 72 arrangement just now, we have to minus the arrangement where 0 is at the first box. So let's see how many arrangement where 0 is positioned in the first box. Okay, so here let's say I have a digit 1 and 5 to arrange. Okay, and for the last box, so we have already used digit 0, 1 and 5. Therefore left only 3 now. 3 options. Okay, so or let's say the first box occupied by digit 0. Okay, now the arrangement of 1 and 5 at the last 2. Okay, so for the second box, the digits that we can put in, we have 3 options here. Okay, so total arrangement. Okay, now see 2 ways, that means to position the digit 1 and 5 itself. So the positioning of digit 1 and 5 to be side by side, we have 2 ways altogether. Okay, times 2 factorial. Why 2 factorial? Because of the arrangement of digit 1 and 5. Next, multiplied with 3p1. Why 3p1? Left another 3 digits. We want to arrange only 1, the blue color box. Okay, therefore total arrangement we have 12. So now in order to find the total number of different codes, okay, so the answer is 72. You have to minus with 12 in order to get the answer as 60. Okay, another way of getting answer for example 10. Okay, now see, first you prepare for, okay, this is the first arrangement. The first arrangement where digit 1 and 5 is being located at the first box and the second box. Okay, now so for the third box we have 4 options. For the fourth we have 3. Okay, total arrangement. Okay, 2 factorial. Why 2 factorial? The arrangement for digit 1 and 5 times 4 times 3 or 2 factorial times 4p2. Why 4p2? Because other than digit 1 and 5 left another 4 digits, but we want to arrange only 2. Okay, so 4p2. Okay, multiply all this, you will get 24. That is the first arrangement. Now, second arrangement where we put the digit 1 and 5, okay, at the second and third box. Okay, so again, for the first box, we cannot put in the digit 0. So eliminate 0, eliminate 1, eliminate digit 5. Therefore, left 3 options. And for the last, okay, be careful. Now you can put in the 0. Okay, that means we no longer have 1 and 5. Let's say one of the digit is already been taken. For example, taken out 2. Therefore, we have another 3 options for the last box. Okay, multiply all this, you will get 18. Next, the third arrangement where you put the 1 and 5 at the third and fourth placing. Okay, so again do the same thing. For the first box, we cannot use 0. So eliminate 0, eliminate digit 1, eliminate digit 5. So left another 3 options. And for the second box, okay, so again 3 digits already been taken out. So now we have another 3. Okay, so multiply all this, you'll get another 18. So total arrangement will be 24 plus 18 plus 18. So total is 60 arrangements. So you have 2 ways of solving this question. So you have to be extra careful when it comes to permutation. Okay, example 11. Example 11 is a case where permutation with repeated letters. So let's look at the example. Find the number of arrangements of the following if all the letters in the given words are being arranged. Okay, let's look at the first one, book. So if you see the word book, you have 2 letter O. Okay, when this is the case, so how to find the permutation? Okay, now see. So here we are going to arrange all the letters B, O, O, K. That means we have 4 letters. 4 permutate 4. Next, you need to divide with 2 factorial. Why 2 factorial? Because the letter O is being repeated twice. So you have 2O, so you divide with 2 factorial. Next, you simplify. Therefore, the final answer is 12. Okay, next, let's see the word laptop. So here, altogether, you have 6 letters where P appears twice. So the total arrangement for all the letters in the word laptop, that will be 6 factorial, because we have altogether 6 letters, divide 2 factorial. Why 2 factorial? Because we have letter P appears twice. So 2 factorial. Simplify and you'll get the answer. Next, question C, downloaded. Okay, so if you see here, the letter D appears 3 times and letter O twice. Okay, so let's see how to find the number of arrangement for all the letters in the word downloaded. Okay, so total we have 10 letters. Therefore, it is 10 factorial over 3 factorial. Okay, why 3 factorial? Because we have 3 letter D, then another 2 letter O. Okay, so 10 factorial over 3 factorial times 2 factorial. Okay, so simplify this and you will get the answer. Example 12. How many 3-letter words can be made using the letters in success? Now, here if you see the word success, you have 2 C and 3 S's. Okay, now we are not going to arrange all the letters. So if we want to arrange all the letters, then you can refer to example 11. But here we are going to choose just 3 letters to form the word. Okay, so it is a bit different from what we have seen in example 11. Okay, now see. First thing, okay, we are going to break this question into 3 cases. The first case is single letter. That means you take out all the letters that we have in the word given. So here we have letter S, letter U, letter C and letter E. And since we want 3-letter word, so here we have 4 letter and we are going to arrange 3. Okay, therefore the answer will be 4P3 equals to 24 arrangement. So this is the first case, where first case is single letter. The second case will be double letter. Okay, so here I'm going to choose 2S. The first set of letters will be, okay, 2S U C E, or the second set of letters will be S U C C E. Okay, now I hope you can clearly understand. Here, since we have 3S and 2C, I'm going to break this into 2 sets, but just double letter. So S, we have 2S, one set, and then the other set with 2C. Okay, so now let's see the first set. Okay, we have letter S, 2 letter S. Okay, so the arrangement of this letter S. Okay, let's see where to put this letter S. So all together, okay, the arrangement of letter S itself, we have 3P2. Why 3? Because we have 3 space or 3 box. And we are going to fill with 2S. So 3P2. Then divide with 2 factorial. Why divide with 2 factorial? Because the S letter appears twice. Okay, now the empty box will be filled with other letters other than S. That will be U, C and E. So we have 3 options here. So times 3. Okay, same thing will happen to the second set of letters, that is S, U, C, C, E. Okay, the same arrangement, same number of arrangement will occur for the second set. So therefore U times 2. So multiply all this and you will get the number of arrangement for the second set or for the second case. Now, the third case will be triple letter. So S can appear 3 times. S, S, S. So triple letter. So the number of arrangement, we have only 1. That will be S, S, S. So number of arrangement is 1. Okay, now you can calculate the total arrangements. So 24 plus 18 plus 1 equals to 43. Now this question is very rare. So I hope you take some initiative to understand this question. Thanks for watching.